All right, so we're going to look at frequency tables today. Okay, so frequency tables are one common way of looking at data, and two-way frequency tables allow us to analyze a couple different variables at a time. Okay, so say we were looking at, what's something easy I can make up? Say we are looking at males and females in the freshman class that are 14 or 15 years old. Okay, I can break that data down and know exactly how many students are male and 14, exactly how many are male and 15, exactly how many are female and 14, female and 15. Okay, and then I can analyze that data and look at the frequency in which there are 15-year-old females in the freshman class, different things like that. Okay. So two-way frequency tables are a way that we can compare a couple different pieces of data that might be changing. Okay, so this first table that we're going to look at is from the Titanic. Okay, so this is information that was collected from the Titanic. So we see, and this is probably a bigger frequency table than we will look at in general. Okay, we really try to simplify them down so that it's not there's not a whole lot going on, okay? So in this frequency table, we can see that there are a couple different things happening, right? So we can see these are the type of people that were on the ship, right? So we have first class passengers, second class passengers, third class passengers, and then crew, or total passengers and crew, okay? And then up top, we have it broken down into a couple different categories. People that were on board the boat, people that were saved, and people that were lost. Okay, so you can see that there are a lot of different categories going on here. There's a lot more happening here than just two different variables being looked at, but we should be able to read and or fill in a frequency table. Okay, so what I want you guys to do is I'm going to leave this one up here, and I want you to go. Okay, so you're answering questions 1 through 4 together with your groups. Go ahead. Page. And I want you to answer 1 through 4 together with your groups, okay? Okay, so we should be able to see from the table that there were 329 first-class passengers total. 173 of those first-class passengers were men. And then 54 of those male first-class passengers were saved. Okay. Any questions there on where I got that data from? Okay. Then it wants me to compare the number, not the percentage, the number of male second-class passengers that were saved in comparison to the third class, and fewer second-class males were saved, right? But if we look at it compared to the number that were there were a lot more third-class passengers than there were second-class passengers, right? So if I looked over at the very last column on the right, you can see the percentages, and there was definitely a greater percentage saved of second-class passengers than there were third-class passengers. So based on the answers for 2 and 3, definitely the third-class passengers were at greater risk of death because the percentage saved was much higher. Okay? So any questions on reading the two-way table? We're all good? Okay. All right. So a two-way frequency table. Okay? So basically what we have to be able to do from those tables is be able to tell what the relative frequency is and what the marginal frequency is. Okay, so we're actually going to skip over this and look at the third page. Okay, so we have ticket class versus fate frequencies. So this is a lot more similar to a frequency table that you would see. As you can see, it's much more simplified. They just took a portion of it, okay? So we see first class, second class, and third class passengers. We see the number that are saved and lost, okay? So you need to notice a few things about this table, okay? Hopefully you realize that all of the first class, so everybody look up at my screen really quick. All the first class, second class, and third class passengers that are saved are all added together to make the total number of people saved. Okay, so in order to find the totals, you got to come across from the label. So the total number saved is just going to go straight down to 492. What's the total number of second class passengers? 285, right? So I come to second class, I come across the total number is 285. How many first class passengers were lost? 130. First class passengers that were lost would be 130. Okay. How many people were on board? Good. 1,000. Oops. Down 5%. 1,324 people was the grand total. That's how many people were on board total, right? So, looking at these different things, I need to be able to find two different things. So, one thing is called. Okay, what was your question?
How come it says 2,223 total on the very bottom row of the graph?
Oh, in the very, very top. I don't know. This may be. They may have just pulled this from a different, or just a section or something like that. I'm not sure. I'm not sure why it doesn't line up with the original graph. But if you were to actually put a calculator to this and add all this stuff up, you would see that there's a grand total of 1,324 passengers. And this number, this grand total, can be found by either adding all the first class, second class, and third class total passengers together. You'd get that 1,324. Or if you add all the people saved and all the people lost, it should be 1,324. Okay? So you can either add down or add across. And that's a good way to check your work, is to make sure that both of these totals end up to be the same thing. That it should always be that way in a marginal frequency table. Okay, or excuse me, in a two-way frequency table. Okay? So two things that you have to be able to find are relative frequency and marginal frequency. Okay? So let's just do this over here. Because we're going to do it a little bit differently than what the Springboard book shows. We're not actually going to put our frequencies into a table. So we're just going to do it over here in the little checkered area. So first let's say relative frequency. Okay. So relative frequency is, what's the best way to put this? A cell count. What did I just do? A cell count divided by the grand total. Okay, a cell count divided by the grand total. So the cell counts are all of these individual pieces in here. Okay, so all of these individual pieces in here. When we say cell counts, we don't look at the totals that are in either the bottom row or the last column. Okay. So relative frequency is cell count divided by the grand total. So if I said, so here's an example. So let's say the relative frequency of third, oh darn it, I keep hitting that button, sorry, of third class passengers lost. So if I wanted to know the relative frequency of third class passengers lost. So what's the number of third class passengers that are lost? 536. Okay, so I do 536 divided by the grand total, which is 1,324. Okay, so then if I calculate that, if I can get my calculator up, there we go. 536 divided by 1,324 would leave me with 0.40. I'm just going to round to two decimal places. So the relative frequency of third class passengers that are lost would be 0.40. Okay? So that's relative frequency. Now let's talk about so this is relative frequency, okay? Now let's talk about marginal frequency. Okay, I'm going to have to move it up and take the box off. I'll come back up to it, okay? So let's talk about marginal frequency. Okay? So marginal frequency, very simply, is a total. Let's use a better word for that. A marginal total divided by the grand total. Okay, so a marginal total over the grand total. So let me pull back up to the box here, or the two-way frequency table. So the marginal totals are the totals for the rows. So these would be our marginal totals down here. These would be marginal totals over here. So it gets a little less specific. So on relative in it, the questions will kind of lend themselves for you to know what you're doing. So a relative frequency will always name two different classifying pieces of information. Like on the last one I said, what is the relative frequency of third class people that are lost? That gives you that you have to find third class people that are lost, right? So that's two different classifying pieces of information. For marginal frequency, I would ask a question like this. So here's my example. I want you to find the marginal frequency of people saved. Okay, so find the marginal frequency of people saved. So I would come up here. I only gave you one indication, right? Is people saved. So when you only see one indication, you know you want to go down and find a total. So what's the total number of people that are saved? 492. So I'm going to do 492 divided by the total, which was 1,324. Is that right?
Yeah.
So 1,324. So then I can go ahead and do that calculation. 492 divided by 1,324 will be 0.37. Okay, so 0.37 would be the marginal frequency of people saved. Okay, so relative frequency is a little more specific. It names two different classifying pieces of information. Marginal frequency is a little more broad and only names one classifying piece of information. Okay, all right, so let's practice this. Okay, so just add a page. Okay, so just add a blank page to your notes, and I want you to fill in this table. Okay, let's say we're going to do let's see, we need 4 columns and 4 rows. Okay, so 4 columns, 4 rows. The top left is always blank. Let's say we're going to do Algebra 1 and Geometry. And we're going to do 9th grade and 10th grade. Okay, so we have Algebra 1 and Geometry. We have 9th grade and 10th grade. Remember these last column, or the last row and the last column are always the totals. Okay, so I'm going to give you some of the information. I'm going to have you fill in the rest of the information and answer a couple questions for me. Okay, so I'm going to give you the 9th graders in geometry are 120. So there's 120 9th graders in geometry. There's a total of 525 9th graders. Okay, I'm going to tell you that there are 205 Algebra 1 students in 10th grade. I'm going to tell you that there are 610 total students in algebra. And I'm going to tell you that the grand total is 950 students. Okay, this is the grand total. This is 950 students. Okay, so first thing I want you to do is there are plugs all over the place.
All right.
Just go sit by one of the plugs and so you can keep doing your notes.
Awesome.
Okay, so that's all of the information that I'm going to give you. Okay, remember all of the columns and rows should add up to the totals. So first thing I want you to do is just fill in the rest of the table together with your groups. Go ahead. Okay, so here if I do 525 total ninth graders. Just wait till we're done, please. We'll be done in a few minutes. Okay, so there's 525 total ninth graders. If I take away the 120 geometry students, 525 minus 120 leaves me with 405 Algebra 1 ninth graders. Okay, so let's double check really quick. Does 405 plus 205 add up to 610? It does, so we know we're good there. Okay. I'm not going to be able to figure out 10th graders quite yet because I need to fill in this box here, okay? So I know that the grand total is 950. So it's kind of like a puzzle, right? You're looking for what you can fill in each. Have you ever played Sudoku? It's kind of like Sudoku. You got to find the missing piece in each row and column. They don't all add up in Sudoku, but you got to have the single number, blah, blah, blah. Okay, anyways. So 950 grand is the grand total. Take away 525 total ninth graders, and we know that there are 425 total 10th graders. Okay, so it's just a big subtraction game. So now I can go ahead and find the 10th graders in geometry. So I know there's 425 total 10th graders. Take away 205 Algebra 1 students, and I know that there would be 220 10th graders in geometry. Okay, and then last but not least, I know that 120 geometry students in 9th grade plus 220 10th graders in geometry should be 340 geometry students overall. Or you could have done 950 minus 610 to get to 340. Okay, so you do have, this is a skill you have to be able to do, is complete a frequency table based on the total and the pieces that are missing. Okay, and then from there, okay, let me shrink this a little bit. I want you to answer two questions for me. First, I want you to tell me the relative frequency of 10th grade geometry students. Okay, and then I want you to tell me the marginal frequency of Algebra 1 students. Okay, so tell me the relative frequency of 10th grade geometry students and the marginal frequency of Algebra 1 students. Go ahead. Okay, so if I'm looking for relative frequency of 10th grade geometry students, I want to first find the 10th grade geometry students, which would be this 220, right? Maybe I should do a different color. Okay, that 220. That still doesn't show up very well. Oh well. So I have 220 students total, or in 10th grade geometry divided by the grand total. So remember, the grand total is always the number that's on bottom. So then I have 220 divided by 950 students, and I get 0.23 would be my relative frequency of 10th grade geometry students. Okay, my marginal frequency of Algebra 1 students, I'm just looking for the total of Algebra 1 students. So that would be the 610. Okay, so I have 610 total Algebra 1 students divided by the 950 grand total number of students. So 610 divided by 950 will give me 0.64. So that's the marginal frequency of Algebra 1 students. And guys, please realize that these frequencies sometimes can be given as percentages, right? So the relative frequency of 10th grade geometry students being 0.23 means that 23% of all the students are geometry 10th grade students, right? The percentage of students that are taking Algebra 1 is 64%. Okay, so that's why I generally tell you to round to 2 decimal places, because we can convert those into percentages. Because 23% of students are 10th grade geometry students, 64% of students are taking Algebra 1. Okay, so it allows us to look at relationships in different data. It allows us to kind of break down. You think about it, if you're taking a survey and you're just taking a complete random survey, but then after you take that complete random survey, you want to know what percentage of your respondents were in certain age categories. You could do a two-way frequency table and figure out, hey, 65% of the people that answered that actually took my survey were teenagers. The other 35% were above the age 18, okay, and were adults, quote unquote adults, okay? So you could do different things like that with it, okay? All right.